Hi guys, welcome to the first lecture of the renal portion of this block for physiology. I am your course director, Tom Shannon, and your physiology discipline director. So let's talk a little bit about the kidneys. I'm going to do a little introduction here, and then our next video will be over the glomerulus, and we'll see how that goes. So the kidney is one of our overperfused organs. So you guys will recall, if you look at the oxygen uptake, the percentage of the total for the body that the kidneys are responsible for taking up and utilizing, they use about 7% of the total oxygen that you breathe in, okay? And that is a measure of their metabolism. So they have a relatively high rate of metabolism given their mass. But even given that, they get way more as a percentage of the cardiac output than they need. So if these were matched, you'd have 7% of the metabolism, 7% of the cardiac output. They get way more than that. They get almost 20% of the cardiac output. And the reason for that is because, as is the case with pretty much all overperfused organs, they have functions that are not... They need blood for something other than matching their metabolism. And in this case, they need that plasma to produce urine. So the function of the kidney, and the reason why it might need more blood, has to do, they're sort of threefold. First of all, they maintain a relatively constant environment. Another way of saying that is they're responsible for homeostasis in terms of water and other substances that your body needs to get rid of, waste substances, things like that. Or overflow, just to keep a balance of those substances. They do that through a process of secretion, that is, the body will add substances to the urine in order to get rid of as much of them as possible, and reabsorption, where what will happen is you will produce tubular fluid in the kidney, and then that fluid may have substances that the body wants to retain. So substances that it wants to retain are reabsorbed, that is, they're moved from the tubular fluid back into the body, and so the body can keep them, and substances that the body wants to get rid of are secreted. They're moved from the body into the tubular fluid. And we'll go over that in a lot more detail later on in this lesson. So your substances are filtered from the plasma into the tubular fluid, and then they are either removed via reabsorption, that is retained within the body, or they are secreted, that is, substances are added to that tubular fluid to get rid of as much of them as possible often, or as much of them as needed. Okay, so homeostasis. The kidney also generates hormones. Renin we'll talk quite a bit about. Prostaglandins I won't talk a whole lot about. Erythropoietin we'll talk about a little bit. Vitamin D is really covered in another block, but we'll talk about that briefly here as well. So we'll talk about a little bit of this, a lot of this, and then other miscellaneous functions that we won't talk about in this renal section a whole lot. Gluconeogenesis and catabolism of peptide hormones we'll leave to other people in other blocks. Or at least other people. So let's take a look at maintain relatively constant environment a little bit more closely. A lot of this and a lot of what's to come in terms of our renal lessons has to do with regulation of water and electrolyte composition of the blood. Whatever you take in has to go out. If I drink water, eventually I have to get rid of that same amount of water somehow. Otherwise, I blow up like a balloon, somebody sticks me with a pin, I explode and I make a mess. We don't want that to happen, so we want intake to balance output, and the kidney is responsible for a great deal of the output. About 95% of all the salts that are output, salts that are let go by your body are let go through the urine. About 60% of all the water is also lost through the urine, okay? So this is a fairly major part of making sure that that output matches the input. Control of body osmolality really goes with number one. By the way, osmolarity and osmolality, basically the same thing. Osmolality is the amount of substance per kilogram of water. Osmolarity is the amount of substance per liter of water. Most of the time, for our purposes, you consider them to be the same thing. So the osmolality or osmolarity of the plasma is primarily, but not exclusively, determined by the concentration of sodium chloride. And so a lot of that balance is maintained through output through the kidney. The kidney can actually output salt and water independently, which, and those are two of the major things that determine this osmolarity. So what happens here is responsible for maintaining this balance, and that's a fairly important thing to maintain throughout the body. Osmolarity needs to be maintained within a reasonably narrow range. Elimination of metabolic waste products to the urine, urea, due to breakdown of protein, uric acid from breakdown of nucleic acids. Of course, you don't get rid of uric acid, you get gout. Elimination of substances from the blood, such as drugs. I'll leave that to our pharmacologists for the most part. If you're not already aware of it, you will be made aware of it exquisitely. A lot of substances, a lot of drugs in particular, are eliminated through the kidneys, and how quickly those substances disappear from the bloodstream is often determined largely by how quickly they're eliminated through the urine. And then finally, we have regulation of normal acid base. We have an entire lesson on this, but for the most part, just recognize that this is done pretty much through reabsorption or production of bicarbonate. And when you add bicarbonate to the plasma, it binds a proton. And so the addition of 1 milliequivalent of bicarbonate is equivalent to losing 1 milliequivalent of protons, and therefore your pH rises. So a lot of your long-term pH regulation is done through the kidneys. We'll talk a great deal about that later on in the curriculum. Okay, and finally, regulation of blood pressure. I think all of you guys are aware of this by now. You retain more water, you increase the blood volume, that increases central venous pressure, and that increases cardiac output. So you do regulate cardiac output and therefore blood pressure largely through what the kidney does in terms of retaining or excreting fluid, okay? In terms of generation of hormones, we have the renin-angiotensin system. Renin comes from the kidney. It's eventually converted to angiotensin in the blood. This is a vasoconstrictor. Our pharmacologists will talk a great deal about that. This process is a big pharmacological target. We have the stimulation of the production or maturation of red blood cells through the production of erythropoietin in the kidney. That causes red blood cell precursor cells in the bone marrow to mature into red blood cells. And that is stimulated through low oxygen levels in the blood, okay? And we have production of the active form of vitamin D. Vitamin D is taken in through the diet, or it's produced in the skin, and then through a couple of reactions, one of which takes place in the liver, and then the last hydroxylation takes place in the kidney. So the kidney is the final step, and it's where the active form of vitamin D, that is calcitriol, is produced. And this promotes calcium absorption and phosphate absorption in the GI tract. So it's very, very important for calcium homeostasis and in terms of maintaining calcium concentration in the blood. That will be talked about in enormous detail at a later date in the curriculum as well. So we'll cover some of this in the way of the hormones, but a lot of it will be covered in more detail later. We're really concentrating on maintaining the homeostasis with the ions and some of the other substances that are important in the urine, as well as water. Water is a big part of the renal portion of this block. Very quickly, I know you guys have histologists which can take you through this stuff in a great deal of detail, and I'm not even going to bother with the anatomy, but the fundamental element for excretion in the kidney is the nephron. There are about 1.2 million of these. That is the structure that you see here. Of course, they're in parallel here in the cortex and the medulla of the kidney. We start with the glomerulus. That's this sort of tuft of capillaries that you see here. And that is fit into a part of the renal tubule, which is called Bowman's capsule. So this is actually renal tubule, and this is blood entering and then leaving the glomerulus, and these are all capillaries in here. Those capillaries fit into that capsule like a glove. And this is the site. The glomerulus and the Bowman's capsule make up what are called the renal corpuscle, and this is where filtration of plasma takes place. So this is where you start creating urine. You take blood, which enters, you filter plasma, and plasma ends up in this Bowman's capsule and in these renal tubules, and it becomes renal tubular fluid. Okay? And this is where the filtration takes place, across the capillary walls, across the wall of Bowman's capsule, and into the tubules. Okay? Reabsorption and secretion start with the proximal tubule. So this is where you have substances being removed from the tubular fluid, taken back into the body, and substances which are added back into the tubular fluid and excreted out in the urine. If it's a waste substance or something that your body wants to get rid of, it'll secrete it and put it back in. That starts here in the proximal tubule and continues on to the rest of the nephron. The loop of Henle is a specialized portion of these tubules. This is where a lot of your water transport takes place, so we'll be talking about that in a great deal of detail. And then you enter the distal convoluted tubule. Once again, more reabsorption and secretion. And then you enter the collecting duct. And usually you have a lot of nephrons that will empty into one collecting duct. And this is also where a lot of your regulation of urine volume takes place. So a lot of the determination of how much you urinate and how much fluid, how much water your body retains, a lot of that is determined in the collecting duct. And we'll talk about that a lot later as well. And then the tubular fluid, now urine, is dumped into the calyces and then finds its way to the urine and the bladder and out of the body. The anatomist can fill you in on that in much greater detail. Most of this block will be concentrating upon what happens right here in this area with these structures, most of the physiology portion of this block, okay? All right, so I think I'm going to cut that off there by way of introduction, and then we'll start talking about the details of how the glomerulus works in the next video. Thank you.